Today we're going to talk about the systems. It's a clean code book by Martin, chapter 11, and he's making this paradigm with cities and buildings and architecture as architecture. So when you have a city, you don't have to know about everything, how it's going on. If you are working for separate concepts, you know how to water supply is going, how the internet connection is going, but you don't have to know about the whole city architecture at all. And coming to the software, when we have a clean code, we can test it because it's the lowest software level. And according to the book, as we follow in the chapters, all functions, all methods, all classes can be tested, and it's if they're following the clean code principles. The same can be done with the highest level of abstraction, its systems, and if it do in a clean way, it can be tested as well. It can be clean, and you don't have to know about the whole infrastructure. You can know about only separate parts, which will help programmers to work in their separate tasks independently. Yeah. So the main point is complexity kills, and the main problem is to separate constructing a system from using it. What does it mean? For example, when you take a look on the hotel which is in the building process, you can see the workers who's working there in the helmets, the different people, the different constructor there. But as soon as the building is ready, as soon as hotel is ready, everything is changing, and people who's living in this hotel already different. They are not workers anymore. They are not wearing helmets. So in software means that construction is kind of building the hotel, and use is kind of using the hotel. And in software, it's a big difference as well. You cannot have building and using in the same place. So talking about software, that means that you have to separate somehow logic, runtime logic, and startup. For example, here what we can see is called lazy initialization, and you can see an example that we create an object only when we will need it. So that means that we first check in if services existing, and if they're existing, then they create an object. If not, if they're not existing, we create an object, and if they're already existing, we do nothing. Why is it bad and why is it good? It is good because startup time can be faster, and we always ensure that we are never returning the null. But this is bad as well because we have a hard-coded dependency here, and we cannot compile without resolving it. And also it might be a testing problem because we have to test at first, is it null or not, and then we have to test what is it doing. Which is coming us to the single responsibility principle, which is breaking here, because the one function have to do only one thing. The one thing should do only one thing. You cannot combine everything in one place. And what is more important is my service implementation the right object in all cases? Is it possible for one type to be the right for all possible contexts? Of course, the lazy initialization isn't a serious problem, but what is need to be done is there are many instances of little setup idioms like this in applications. And the global setup strategy is scattered across the application with little modularity and often significant duplications. Option 1 is to separate construction from the use, is move all construction to main. Main function builds objects necessary for system and passes to application which simply use them. And application has no knowledge of main or of the construction process. As you can see, that all arrow dependency is going out of main. And sometimes we need to make sure to make the application responsible for when an object gets created. We need to pay attention for order processing. For example, this is an abstract factory pattern to give the application control of when to build the line items, but keep detail of that construct separate from the app code. And again, we can see here that all dependency points are going from main, so main doesn't know anything about order processing. So we have to somehow separate it. And the question is how to do it, and powerful mechanism to separate it, construction from use, is dependency injection. Object should not take responsibilities for initialization dependencies itself. It should pass this responsibility either to main routine or special purpose to containers. Right. So this is a big myth that we can get systems right from first time, and better to implement today's story and then the refactoring. Then after refactor what we have. So the main purpose is start small and then we can add it feature later. And now here we come into the cross-cutting concerns, which is a problem existing when we have one method and in this method we have some function like something the core concern. But as well we have something which is calling side concerns. So let's say the business logic asking you, for example, to have a bank application where you need to have create an account, for example, right? But later on, your business owner asked to add some features, like he asked to add loggings there. So he wants you to save logs every time when the method is called, right? So, thank you. And this kind of logs will be repeatable tasks.
Appear in many patterns.
Appear in many patterns, right. Yeah. And there is a possibility to decompose the side concerns which appear repeatably in many patterns. And this problem can be solved by aspect-oriented programming, which is a paradigm with many solutions. And as you can see here,
should I?
Yes, please.
What should I?
So now I need some help.
Okay. Okay, so let's see this method. This is transfer. The core concern of this method is to transfer an amount of money from the account to the account. This we call the core concern, right? And there are many requests coming to validate the user which is actually wants to transfer the money. Here is the user authorized it, and whether the money has the amount of, or the right amount of money. And this throw new exception, this is called side concerns. And these side concerns are appearing in many methods, not just in transfer, but in other kind of methods, like in the withdraw, like. So this, the main problem which is solved by aspect-oriented programming is that it's decomposing those side concerns from the core concerns and implement it in decomposed way, but giving the possibility to join, to pass these codes, snippets into here. So, so with aspect-oriented programming, for instance, you can create an aspect which is doing this, and you can, and this is called the aspect, and there are joint cutting, right? Yeah. Joint cut, where you can define where to join this kind of aspects to the code, which method, and before it, or around it, or after it, or return call, for instance. And a point cut is when the join cut and the aspect is meeting to each other, and it's passing or joining the code, and it's executing it. So every time, so you are creating two aspects, here the authorization aspects, and here the balance check aspects. And you are creating outside, and you annotating the transfer method to that aspect. So every time the transfer method is called, the aspect is executed based on when the point cut is happening, before or after or around. And the beauty of it, you need to define those aspects only once. You define it where to actually execute it, and you are decomposing the side concerns from the core concerns, and in that way you are making the code cleaner. That's the aspect-oriented programming basic idea. And can you? Yeah.
Next one.
Yeah. Next.
The paradigm.
And the solutions for the aspect-oriented programming can be using, for instance, frameworks. We can use or Java proxies. One of the solutions is Java proxies, which is actually mentioned in the book. And it is basically, you can create a proxy object which is by reflection invoking the target method. So you are wrapping the target object you are want to invoking the method. So for instance, if you go to the next slide, sorry, here the proxy Java object has an invocation method, and an invocation method inside you can define the method name which we want to call, and the method name, if for instance equal to get accounts, then this is the side concerns which is fetching, which is not implemented into the get accounts, and this is the side concern that this is fetching data from a database and setting it to the accounts, and the main core and the core concern of the bank accounts is to giving the accounts back as a collection, and it's done when this method is called. So this is the side concern which is done controllably, and this is the core concern which is done, and it's covered by a proxy. This solution is not the best, but it exists, it's simple, and everybody can use it, for instance, in Java. And in C# also reflection exists, so you can do it also. In C++ you can use, for instance, macros for it. Anyway, we can go to the next, I guess. And the other advantage of the aspect-oriented programming and the whole inverse of controlling decomposition, where we're using factories instead of instantiating the object in place, is that the system is more testable. You don't have to mock dependencies just testing one unit because you decompose it by a factory object. You need to by the way mock the factory, but not every actually mocking object. And on the other hand, when you're using aspect-oriented, those aspects are decomposed, so you can write unit tests for the core concerns, and you don't have to write unit tests for the side concerns. You don't have to write unit tests for the verification because it's decomposed in an aspect, and only for the core concern. So, yeah.
The goal is to test system architecture just as a code, and it can done with those system architectures which follow in these rules, which consist of modularized domains of concern. So yeah, to summarize, what we need to do is optimize decision making, to use standards wisely when that demonstrable value, and system need domain specific language is. Right? So at all levels of abstractions, the intent should be clear, and we never have to forget to use the simplest thing that can possibly work. That's all. Thank you.